Okay, in the last video, I just to show you that uh, anisotropic um, growth can be simulated, although it is not that perfect due to the use of a free space growth kernel. But anyway, that will take some time for me to eventually fix all kinds of disadvantages or problems in my current implementation. Anyway, I have to prepare this year's TTCO course, so I will just move on to the fabrication procedure. So let's continue here. Previously, we have made spacers. So just nearby dummy gate, we have made spacers. After that, we will do two things. One thing is cavity etching. So now we have uh, dummy gate, spacers, and there is a fin just exposed to the external environment, and that will be etched away. So here we have dummy dielectric and fin. This is corresponding to the silicon, and they are etched away. So now we will have cavity that CGNS. So its shape is actually the same with the previous one, which is made of two side walls and one bottom substrate made of silicon, but in this time the material name is fin, and after that I will just grow silicon germanium only from fin or silicon germanium. So you can easily understand this is corresponding to the previous setting for anisotropic growth of silicon germanium epitaxy, and after that I will just make it twice. So since its bandwidth is set as 10, so it means that at each step it will expand 10. So if we repeat this twice, then we will have 20 wide structure from the center of this structure. Since we have several fins, actually three fins in N-type and P-type region, so they will be eventually merged. So you will see that in this source drain.cgns file. So let's just get started with spacer.cgns file, because this is the previous stage of our fabrication procedure. So, okay, so maybe you can you can recognize that previously there was a level set 0 and bedrock, but they are all eliminated in this display. Although they are still there in my code, but in this visualization, I don't show them any longer. And let's go to the color. So, uh, due to the omission of these two reasons, so now our color code are different. Please understand that one. Yes, this is the previous case. This is nothing new. These yellow ones are corresponding to the dummy gate, and this purple one that are corresponding to locate spacer. Uh, After that, now you can see that there is a certain exposed fins, and that will be the starting point of our source drain growth. So the next part is just to make a cavity for that part. So cavity dascigenes. So we select it. Now you can easily understand previously there was a fin, however there is no fin at all, and this red one is actually corresponding to the silicon fin. So however here we don't have any fin, so let's just have a look at the shape once again. So eliminating spacer, dummy gate, and here, then we can clearly see that there is only fins. And in the last video, I just show you small part of it. So here, two side walls and one bottom silicon fin was considered, and from this small structure, we perform the source drain epitaxial growth. So that was the yesterday's situation, and now we will try to make the same structure, however in this time for this fins, a set of fins. So let me just show you the structure source drain dot cgns. So what we expect is the growth of a source drain layer, and as we expect, yes, now we have this structure. This is corresponding to silicon germanium. So when I highlight it, silicon germanium, yes, you can see that they are silicon germanium. So without lowercase spacer and dummy gate, let's just show only fin and source drain, and now you can see that this is the structure after source drain epitaxial growth. So of course, as I told you before, so when we consider the realistic structure here, we have also certain diamond shape. So here we have another one surface. However, it does not appear here. And here we have also something. This is of course called as overgrowth. However, overgrowth is seems to be too high. I'm not quite sure. And also we can see that there exists still clear one surface along this and that. So these are corresponding to two origin of epitaxial growth, one fin and the other fin. However, in reality, they are merged and converted into one single structure that is not considered in this implementation. Okay, so now everybody understands this is not the perfect implementation. Anyway, but still we have FinFET procedure. So yes, we will just continue this job till the end of our final description. Yes, so after that, once this procedure is over, then I will come back to the physical description of more uh, steps, so we will have a better result for our process emulation. But I think that right now it is just on track, and I will come back to you with different examples. Thank you and see you later.